Okay, so here I want to go over number 11, which is to factor this quadratic. And I'm going to, again, try to use the AC method. So our A value times our C value, so 9 times 16. Let's see what we get for that. We get 144. So what I want to do is find two numbers that multiply to 144 that also add to negative 24. So think about if I have to multiply to a positive and add to a negative number, both of these numbers have to be negative. And then it's just a matter of finding out what they are. Off the bat, I'm thinking maybe negative 12 and negative 12. And we got to see, do those multiply to 144? Yes, that's why I picked them. And if I add negative 12 plus negative 12, do we get negative 24? And the answer is yes. So it means I picked the two correct numbers. If not, you have to kind of still guess and check and play around to see what multiplies to 144 and adds to negative 24. Once we find that, 9p squared we leave alone, and then the negative 24p we're breaking up using the negative 12. So negative 12p, and then another negative 12p, and then the plus 16 stays as it was. And then we're factoring by grouping. So the first two terms, let's see, what do they have in common? Well, they have a p in common, and they also have a 3 in common. So I'm going to pull out 3p. To get back 9p squared, I would need 3p. To get back negative 12p, I would need a minus 4. And then group up the second set of terms. What can I pull out of negative 12 and 16? Looks like a 4, and because there's a minus here, we need to pull out a negative 4. And then to get back negative 12p, I need 3p. To get back positive 16, I need a negative 4. So these match up, which is how you know you're on the right track. So we get 3p minus 4. And then times whatever's on the outside, 3p minus 4. So if you notice, it's the same binomial multiplied by itself, which means we can actually rewrite it as 3p minus 4 times itself, which is to say squared. And when this happens, when you can write the original thing as something squared, that means we can call the original a perfect square trinomial. Trinomial because the original had 3 terms. Perfect square because we can write it as something squared.